So, second experiment is saturation experiment. In this experiment, we are going to use something called Soxhlet extraction or Dean-Stark extraction. It's an extraction of the fluids inside my core by the use of distillation. So, what we do is we have a flask, and this flask has toluene, and we heat the toluene so that it evaporates, and then it passes through a chamber that has my core, and my core is saturated with oil and water. So usually the boiling temperature of toluene is higher than water, so when it goes around the core, it causes the water to evaporate as well. And then both the water and the toluene, they go up to a condenser that has a very low temperature, and this condenser causes both of them to condense and drop back around the core, and then with siphon effect, water and toluene go back into the into some kind of graduated cylinder. And this graduated cylinders, in this graduated cylinders, they separate based on their density. Water at the bottom and toluene along with the oil that was saturating the core at the top. And then when the graduated cylinder is full, the fluid at the top starts dripping back into the flask. We will see the setup at work. It's running right now, but before that we need to know what we are going to calculate and what data are we going to need from this experiment. So for this purpose we need saturations. So we need water saturation and we need oil saturation. And since my core doesn't have anything other than the water and oil, then the total saturation or the oil saturation is 1 minus the water saturation, because saturation is a percentage of the pore volume. So water saturation is the volume of water divided by the volume of pores. So my objective in this experiment is to get the volume of water inside my core and the volume of the pores inside my core. How do I do that? We know that the volume of the pores, since the pores are totally full of oil and water, it should be equal to the volume of water plus the volume of oil inside my core. How do I get the volume of water? This is easy. This is what my experiment will give me. So after the end of the experiment, we leave it running for several days or several nights, and then we come and we collect the volume of water inside the graduated cylinder. This volume of water will be the volume of water that was inside the core. Why? Because there is no other water inside the system except for the water that was present in the core initially. And the volume of oil. How do I get the volume of oil? This is the issue here. We don't measure the volume of oil. We actually calculate the volume of oil. We know that the volume is mass over density, mass of oil divided by density of oil or raw oil. So what is the mass of oil? If I get my core before the experiment, when it was full of oil and water, and measure its weight, and then after the experiment, after I dry my core and leave it in an oven and it has no oil and no water, I measure its weight again, which will be the dry weight. So now we have a wet weight, or the wet core weight, and the dry core weight. The difference between them is the weight of oil and water. If we subtract from that the mass of water as well, then we have the mass of oil. But how do I get the mass of water? We know that the mass is also volume by density. And since I know the volume of water from the experiment, from the graduated cylinder, if we multiply that by the density of water, which is 1 gram per cc, now I know the mass of water. So this is basically a calculation. The only unknown in this term is the volume of water, which we will get from our experiment, and we will substitute with it here as well. The second thing that you may ask, how would we know it, is the density of oil. But actually we can measure the density of oil with a densitometer or any other instrument, so that's not a problem. After we get the volume of pore and we have our volume of water from our experiment, we can get the saturation of oil, of water, and from it we can get the saturation of oil. So now let's head over and see how the experiment is going. Okay, so here's my system. We call it Dean-Stark distillation extraction. So at the top here you have what we call a condenser, and then this is the chamber that has my core, and this is the siphon where it discharges all the fluids to a graduated cylinder. And in this cylinder the fluids will be separated by density, so that the fluid that has lower density, which is the toluene mixed with the oil, will go back into the flask that has the boiling toluene. So the idea would be like this. We have toluene here, toluene is boiling, we add some boiling chips so that the toluene doesn't overheat because it may explode or cause a problem, and we don't want that to happen. And then the toluene starts to evaporate. The vapor of the toluene goes around the core, and it has very high temperature, higher than the boiling temperature of water, so that the water will also evaporate. And then we'll go into the condenser, both of them, and we have a stream of running cold water inside the condenser, and this is why the both of them start to condense around my core, as you see here. And when they reach this level, the level of the highest point on the siphon, as you will see probably in a minute or so, the fluid will siphon back down to my graduated cylinder, and after that any additional fluid, the lighter one, will go back into the toluene. We keep this going for a long time until all the fluids in the or all the water and oil inside my core are already outside my core. The water is here, the oil and the toluene are going down into my flask, and only the toluene is evaporating back and cleaning my core. So there are two mechanisms here. First mechanism is, okay, now you see the siphon effect. This is when all the fluids drip back into my graduated cylinder and then to the flask. So there are two mechanisms of work here: the temperature and dissolution. So the temperature causes the water inside the core to evaporate, and the toluene that comes from the condenser, when it leaches or goes into the pores of my core, it dissolves the oil and causes the oil also to go out of the core by immiscibility. So this is the idea of the saturation experiment. In the end we will find like two fluids here. One of them has the water will have a smaller level depending on its saturation, and the rest will be full of toluene and oil. So we'll measure, you will see that this is a graduated cylinder, so we'll measure the volume of water and give you this volume. This is a summary of this experiment.